share Zoom. And here's our sheet. Hi, Susan. Hi, Colin.
Hi.
Hello.
Well, as usual, you totally screwed up the link, so. Never change your link mid-semester. Okay, Yitzi, take it away.
Okay, well, so Lenny, thank you so much for making the time. Everybody, we are super lucky and honored to have Lenny. I'll give a brief intro of why we're super lucky to have him join us. He has a BS of ECE from Carnegie Mellon. He studied, got a systems master's at the University of Denver. For the Navy, he led the NASA Mission Control Center as the model architect and model-based systems engineer. He is an educator, so he's going to be really good at this session because he knows how to educate, which is great for us. And currently he is the founder, CEO, and principal consultant of Delligatti Associates, which is a model-based engineering training and consulting company. But we all know him and love him as the author of our textbook, SysML Distilled. So at this point in our course, we've read every single chapter and have been quizzed thoroughly by Wes on every single chapter. So we are very excited to hear from you. And we thank you so much for making the time. And just a public disclaimer, I apologize for making the flyer with a picture of the Mars rover because Lenny said nowhere in his email did he mention he would discuss that, but I thought it was the coolest use case that I've ever seen. So
it was a good picture.
It's a cool picture. So I don't know if he's going to cover anything on that. If he is, that would be great. If not, that's my fault. I apologize. Without further ado, thank you so much, Lenny.
Okay, Lenny, so you can now take over sharing if you want, I think.
Sure. That, of course, assumes that I know how to work Zoom. Let's see here.
Yeah.
Share screen.
Yeah, we're old hats at Zoom now. Yeah, you should be able to go to share screen. There you go.
All right. And just confirm that you guys can see my screen.
Yep.
Hi. So, so folks, I'm LennyDelligatti. Thank you all for inviting me to come talk to you this evening. I really do appreciate it. It's an honor. Quick, and Yitzi, thank you so much for covering the bio. You just saved me many minutes of covering my bio. That was very succinct. I appreciate that. So I'll just dive right into the content because this is what you guys are all here for. So the focus of this presentation is on use case heuristics. Now, I'm going to go through the concept of what a use case is and some heuristics on how to brainstorm good use cases. That's really the focus of this presentation. Now, this particular discussion is an excerpt of a training course that I deliver at my company, Delligatti Associates. So what you're seeing on the screen right now is the handbook of that course, and I'm going to be referencing this throughout the presentation, and also switching back and forth between Cameo and that handbook. So to provide some context about the value of developing and modeling use cases. Use cases really are stakeholder level functional requirements. They are actors' goals that actors can achieve by using your system of interest. So really, that's another way of saying a use case represents a stakeholder requirement, a stakeholder level functional requirement, something that a stakeholder or user of the system can achieve by using your system of interest. And I'm going to talk you through later where use cases come from, what the input to this particular activity is. But I want to begin with a set of key ideas and heuristics, what use cases are, and how to brainstorm good use cases. And then I'll take you through the thought process for applying these heuristics to a set of stakeholder concerns to derive use cases. So here's the first key idea. And if you guys, you're all students under Wes, so I'm sure you are excellent note takers. So I would strongly encourage you guys to take notes if you've come prepared to do so.
Yeah, no slides, everybody.
Idea. What's that?
No slides, everybody.
That's right. Yeah, I I do not like slides very much. I tend to be as very hands-on as I can be. So yeah, so hopefully you guys have some medium to take notes with, either a Word document or pen and paper, whatever works best for you. But here's the first key idea that I'd like you to write down. A use case represents a behavior. A use case represents a behavior. And that leads to this first heuristic for brainstorming good use cases. When you name your use case, you should give it a verb phrase for a name. And I prefer using the infinitive form of the verb. So here's a good example.
Iterate.
Initiate telemetry download. That is a verb phrase. That sounds like a behavior. By contrast, here's a bad example. Telemetry downlink initiation. That's a noun phrase. That's less clear that you're describing a behavior. That almost sounds like an event occurrence, perhaps, not a behavior. So as a matter of methodology, not language law, but as a matter of design methodology, you want to give your use cases verb phrases for names. Make them sound like behaviors because that's what they represent. And feel free to stop me if you have questions, otherwise I'll keep rolling along. Next key idea that I want you to write down. A use case represents a behavior. That actors either invoke or participate in. Use cases represent behaviors that actors either invoke or participate in. And if you're not familiar with that concept of an actor, here's a quick explanation of what an actor is. Here's the notation for an actor, stick figure in SysML. And the concept of an actor is simply this. An actor is any entity, human, system, or inanimate object. Any entity, human, system, or inanimate object that is outside the boundary of your system of interest. That is outside the boundary of your system of interest. And that interfaces with your system of interest. So flight controller, a human actor that interfaces with the DelSat would be an actor with respect to that system of interest. And now back to my original point. A use case is a behavior that an actor either invokes or participates in. It is not an internal system behavior. It is not a behavior that the system performs all by itself. It's a behavior that an actor invokes or participates in. So here's a good example. Create operator profile. If you were to write out the narrative for that use case behavior, and you have steps that actors perform, then that would be a valid use case behavior. By contrast, save operator credentials in database. If you write out the narrative of this behavior, then you discover that this is a behavior that the system is performing all by itself, then that's not truly a use case. That's an internal system behavior. And so heuristic number 2 is very simple. Do not model internal system behaviors as use cases. You should certainly model internal system behaviors in the form of an activity or a state machine or an interaction in SysML form, but don't represent it as an ellipse, as a use case element within your model, because it's not. Next key idea. A use case is a communication tool. A use case is a communication tool. It communicates to your stakeholders what your system can do for them. It communicates to your stakeholders what your system can do for them. To succeed as a communication tool, it has to be clear. It has to be unambiguous. And that leads to heuristic number 3. Begin each use case name with a strong, unambiguous verb. It's not enough for it to be a verb phrase. It has to be a clear verb phrase. For example, here's a good use case. Delete operator profile. Delete is a strong, unambiguous verb. By contrast, here's a bad example. Manage operator profile. Manage is an ambiguous verb. That fails as a communication tool. And several years ago, I was sitting in a design review where the designer was presenting a use case that sounded a lot like manage operator profile. And she's talking through this very complex behavioral narrative with many different paths of execution running through it, and many different decision points laced throughout. And at one point, I just stopped her and I asked her, can you just back up and tell me what you mean by manage? She said, sure. Well, here at the beginning, a flight controller can create an operator profile. And down here at this decision node, the flight controller can branch off and optionally read an operator profile. And over here at this decision point, they can branch off and update an operator profile. And down here at this decision point, they can optionally branch off and delete an operator profile. You know, manage. And I told her, you realize what you just did. You just came up with 4 much better use cases than manage operator profile. Create, read, update, delete. So my advice to her was to get rid of this poorly named use case and replace it with that better set of use cases, where each one is more refined, where each one is clearer, less ambiguous, and where each one is more narrow in scope. It becomes an easier story to tell. So when you brainstorm use cases, you want to come up with verb phrases that begin with a strong, unambiguous verb. Next key idea. A use case represents an actor's goal. A use case represents an actor's goal. A goal that an actor can achieve. A goal that an actor can achieve by using your system of interest. I'll say the whole thing again at full speed. A use case represents an actor's goal. A goal that an actor can achieve by using your system of interest. And that leads to heuristic number 4. When you write that use case name, the verb phrase, write it from the perspective of the actor, not the system. If a flight controller has a goal of sending a command, then you should name that use case send command, not receive command. Write it from the perspective of the actor, not the system. So these 4 heuristics help you brainstorm good use cases. Now I'm going to take you through the thought process of applying these heuristics to derive a set of use cases from stakeholder concerns. Before I do that, do you have any questions for me?
Any questions, anybody? Let Lenny have a drink there.
It was a good
Hi.
opportunity to pause and
Yeah, hi, I do have a question.
Yes, sir.
Yes, hi. Well, first of all, thanks for sending an invitation. I'm not a student, but I am an engineer working on the transportation industry with system engineering. So I do appreciate. In this case, it's if your actor is not a human being, it's another system. Do you write the use case from the perspective of the actor behind that system?
Of course. Oh, well, okay. So you could be asking me two different questions. Maybe you're asking me, is that system itself an actor? And thus, is its goal a use case? And the answer is yes. As I mentioned earlier, when I gave you the concept of an actor is any entity, human, system, or inanimate object that's outside the boundary of your system that interfaces with your system. So yes, even an external system could be an actor. And thus any behavior that that system invokes would rightfully be modeled as a use case. Now, you might instead be asking me a different question, one that relates to the idea of levels of abstraction. You said the actor behind that system.
No, I meant the human being behind the actor system. Yep.
So to be clear, you could represent either a human being sitting down at the console as the actor invoking the behavior, or perhaps you could represent the ground system console as the actor that's invoking the behavior. Now we're talking about levels of abstraction, right? If I send an email to you, you could say at a certain level of abstraction that I am connected to you via email, and that would be a true statement. But that's really an abstraction of the truth. The truth is there are many layers of protocols in between you and I, right? I send an email in Outlook that gets decomposed into SMTP packets, decomposed into TCP, then IP, then Ethernet datagrams, sent out over a Cat6 cable to my wall, to my router, to the DSN server, and then down the stack through your DSN server, all the way up through your computer, and now it pops into your inbox as an email. So both statements are equivalently true. I am connected to you via email, or I am connected to you via this OSI stack of protocols that are in between you and I, right? So it becomes a matter of judgment which entity you represent as the actor that's invoking that behavior. Is it the flight controller sitting at the console, or is it the computer itself that the flight controller is typing something into? And that question is only answered by you and your stakeholders. You and the target audience that you're modeling for determine what level of abstraction is appropriate for that target audience. There is no right or wrong answer.
Okay, clear. Thank you very much.
Very good question.
Yeah.
Okay, thank you, Lenny. Go ahead.
All right. So now that I've put these 4 heuristics into your head, let's give these a test run. Where do use cases come from? So when I teach our MBSE methodology training course, I walk course participants through the activity of modeling stakeholders and then representing stakeholder concerns. Now, I'm not going to take you through that entire activity, but that's an hour lesson in and of itself, separate from the focus of today's presentation. But suffice it to say that what you're seeing here in this matrix is a mapping between stakeholder concerns and a set of stakeholders. And it's a many-to-many mapping. A single stakeholder can have many concerns, and a single concern can be shared by many stakeholders. And so a matrix becomes a useful medium for representing that mapping. So this artifact that you're seeing right now, the stakeholders and their concerns, that is the raw input to the entire systems engineering lifecycle. It begins with identification of stakeholders and their concerns. We then derive all other products, either directly or transitively, from that set of stakeholder concerns. That set of stakeholder concerns is the raw input to the lifecycle. It's what I refer to as the primordial soup of systems engineering. And concerns, as elicited from stakeholders, could take various forms. They could be questions that stakeholders want an answer to. They could be stakeholder needs, some goal they want to achieve. They could be constraints imposed on process or system. So concern is this broad umbrella that encompasses all of those things. And as we know, stakeholders sometimes express their concerns in nebulous, ambiguous ways. You know, Henry Ford famously said, if I had asked my customers what they needed, they would have said faster horses. It's this idea that stakeholders don't always know what they need. What comes out of their mouth is not always a well-formed expression of their needs. And part of the art of systems engineering is applying those soft skills to interact with a stakeholder, asking those critical questions to both shape their thinking and elicit from them what their actual needs are. So sometimes concerns might be fairly nebulous expressions, and it's our job to refine them into something that's clear and actionable. So that's a really quick introduction to what stakeholder concerns are. And that's what you're seeing here in this package called stakeholder concerns, and displayed in the form of a matrix as shown here. So now for the thought process. Where do use cases come from? Well, the answer is they come from stakeholder concerns. The design team, led by the system architect, sits around that table and they have a discussion. They work their way down this list of stakeholder concerns one at a time, applying those 4 heuristics that I taught you to mine from these concerns use cases. And this is as much art as science. And as with any creative endeavor, no 2 design teams will necessarily produce the same result. No 2 poets write the same poem. No 2 system architects will design a system in quite the same way. They will apply their judgment and experience and training to make design decisions. That's a creative endeavor, and no two designers will ever produce quite the same result. So this is very much an art, working with team members and stakeholders to mine from these stakeholder concerns a set of use case elements. But here's how the thought process goes. They focus on the concerns that are mapped to actors. Actors are a subset of stakeholders. Actors are a subset of stakeholders. Actors are the stakeholders who will interface with your delivered system of interest. And I taught you a few minutes ago that a use case represents an actor's goal. So where do use cases come from? They are derived from concerns that are mapped to actors. They do not come from non-actors, where a non-actor is a stakeholder who shapes the design of your system, but doesn't actually interface with the delivered product. And they do not come from internal stakeholders, members of your team, whether you're part of the acquisition organization or the development organization. Those team members would be the internal stakeholders. You can focus specifically on the subset of concerns that are mapped to actors, because that's where use cases come from. And so now the team works their way down this list, one at a time, applying those heuristics to mine from these concerns use cases. So they look at this first concern. which is mapped to the flight controller actor. And the concern is as follows. And I know this is hard to see, so I'll read it out loud to you. For what duration should thrusters fire for each of the 2 impulses required for a Hohmann transfer? And now the team gets to work. They apply those 4 heuristics to that stakeholder concern. They try to mine from this concern a verb phrase that is clear, that represents an actor's goal, that an actor either invokes or participates in. And now they talk. And one team member suggests, how about fire thrusters? That's a verb phrase. That's clear, she says. But then another team member speaks up and says, yeah, well, I don't know, fire thrusters, that kind of sounds pretty low level. That kind of sounds like an internal system behavior, not really an actor's goal. That kind of sounds like a step as part of some larger use case narrative. And this is the discussion that happens back and forth at the table when the team tries to derive use cases from stakeholder concerns. Now, design by committee never works. I think we've all experienced that firsthand. So there has to be a team leader who acts as the arbiter, who steps in and makes the final decision once a time-bounded discussion has completed and all input has been heard. And we call that team leader the system architect, the captain of the ship, the chief surgeon in the operating room. System architect is the person whose job it is to ensure the conceptual integrity of the system as a whole. Not a micromanager, not a dictator, the arbiter who gets to make the final call once all input has been heard. The one whose job is on the line if that system fails and kills someone. And every team should have someone serving in that role, system architect. So the system architect is listening to this discussion, the different team members tossing ideas back and forth. And ultimately, she steps in and she makes a final decision. You know what? Fire thruster sounds too low level to me. That doesn't really strike me as an actor's goal. That's not really a true use case. Let's move on to the next concern, she says. Now, to be clear, design is iterative, cumulative, and recursive. First draft is never the last draft. First decision is never the last decision. So the architect makes the decision that seems right to her at that moment in time based on her experience and training and judgment. But of course, design is iterative. She can always iterate back to this decision and change her mind later if she discovers that there's a compelling reason to do so. But maybe at this moment in time, she decides that fire thrusters is not really a good use case. It's too low level. So she tells her team, let's move on to the next concern. This one here is also mapped to actors, so they pause to consider it. Since the satellite's parking orbit and final orbit are coplanar, we plan to execute a Hohmann transfer to minimize fuel consumption during the maneuver. Now the team talks. They try to mine from that concern a verb phrase that is clear, that represents an actor's goal that an actor either invokes or participates in. And one team member suggests, how about execute Hohmann transfer? That sounds like a goal that a flight controller or a NASA mission manager would have. A behavior that one of those actors either invokes or participates in. System architect says, I agree. Let's jot that down as our first use case. And they make a note of that verb phrase, execute Hohmann transfer, mapped to NASA mission manager and to flight controller. And now they move on to the next concern. Now, this particular concern is not mapped to an actor. It's mapped to a non-actor, And that's not where use cases come from. Maybe this concern will lead to some other artifact. Maybe this concern leads to a constraint, not a use case. So the team simply moves on to the next concern. And they work their way down that list, one concern at a time, applying those 4 heuristics as they go, until finally they get to the last concern in that list, captured in the model, and they can now say with complete confidence that we have a complete set of use cases. And that sounds like a rather bold statement to make, right? A complete set of use cases. How do you ever know that you have identified a complete set of something? That sounds like a daunting proposition, but it's actually quite simple. Completeness is always measured with respect to the input that came before. In this case, use cases come from stakeholder concerns. So with respect to that precursor, a team can say, we have identified all use cases based on that set of stakeholder concerns. Now, let me be very clear with you. That list of stakeholder concerns is a moving target. It's not a static list. Stakeholders can express new concerns at any point as the life cycle progresses. So what happens if a week later or a month later, a stakeholder expresses a new concern that wasn't there before in the model? No worries. You simply go back to the beginning of the modeling method, the process, and you simply apply all activities again now to that new concern. And now with respect to that new concern, maybe you derive another use case that you didn't have before. And now you have once again returned your model to a state of completeness. Completeness of an artifact is always measured with respect to the precursor that came before. And now you know where use cases come from. They are derived from stakeholder concerns. Now, I know that was a lot to absorb, so let me pause and see if you have any questions for me.
Go ahead, anybody?
I think we are
know-
good.
Go ahead.
I think we are good. Thank you.
Oh, appreciate the feedback.
Lenny, I had a question.
Yes, sir.
Let me see. So stakeholder concerns. That's always that's a great input. The question is what's the best process to gather those? Because based on the kind of customer you have, it may or may not be easy to get those, right?
It's usually not. Yeah. There's no silver bullet answer. Concerns can arise in an informal setting. Maybe you're in a one-on-one meeting. Maybe it's an email that arrived, or maybe it's a formal setting. Maybe it's some life cycle gate, system requirements review, mission requirements review, preliminary design review, critical design review. So concerns can be expressed at any point during the life cycle. And one of the hardest things to do is to, again, ask those critical questions, to not just be a scribe for what comes out of the stakeholder's mouth, but to actually shape their thinking to determine what their actual concern or need is. So there is no silver bullet answer for how to elicit and capture concerns. You capture what is expressed after some interaction back and forth, with the understanding that you can always go back later and refine them as you better understand what the need is.
So would you say that there should be someone designated as a keeper of these stakeholder concerns, right?
Yes.
But everyone should be responsible for possibly developing or discovering a concern so it can be vetted by your team. Is that a pretty
Yes.
good process?
You summarized it perfectly. And of course, the devil's in the details, right?
Right. Having a process that does this.
Exactly. Because, it all goes back to configuration management. You don't want every member of the team to haphazardly add new concerns to the model without some cognizant engineer vetting it and approving it. Because what gets captured as a concern in the model, in effect, becomes part of the project backlog that the team is working toward, right? So you don't just add them blithely to the model. They have to be vetted by somebody who's authorized to do so. System architect, project manager, someone in that position. So now I'm sorry, go ahead.
Oh, one of the things we've been working at our school is another related engineering process called design thinking. And several of my students are involved in that process where you're soliciting your concerns, right? You're trying to ideate, you're trying to immerse yourself in the customer's problems, because the output of that process in design thinking is to really come up with those stakeholder concerns. I think my students would agree with me.
Yeah.
And this is another excellent way. And when we looked at design thinking, we said, how do we integrate design thinking with system engineering? And I've always concluded use cases was where the rubber kind of meets the road. And I think it's an excellent segue for that interface, I think.
No, I agree. And the only caveat is, of course, that use cases are not the only artifact that is derived from stakeholder concerns.
Okay.
Constraints, for example, would be another place where, as you say, rubber meets the road. But yeah, certainly use cases fall in that same category.
Right, because they're not formalized till they become requirements.
Yeah, and that question of what a requirement is a separate question entirely. Normally, when we hear the word requirement, we think shell scheme, right? System shell or stakeholder.
Right, they're formalized.
So that's certainly the traditional way that we think about requirements. My mission in life is to reframe the way people think about requirements. As I said to you at the very beginning of this lesson, presentation, sorry, I'm in teacher mode here.
Yeah.
At the very beginning of this presentation, use cases are, in effect, stakeholder level functional requirements.
Right.
They're not expressed in the form of an English language paragraph of text that begins with stakeholder needs or system shell, but they are very much stakeholder level functional requirements. They are expressions of what stakeholders need your system of interest to do. So I am a proponent of the practice of using use cases as stakeholder level functional requirements without having to engage in this kludgy process of now turning them into paragraphs of English language text. But you're right in that that's what we typically think of when we hear the word required.
Okay, good. How would you compare them to capabilities? There's another buzzword.
Yeah, so capability is a term defined in DODAF, and thus the UPDM language. And typically we write capabilities as noun phrases, right? Attitude measurements, orbit control, right? We write them as noun phrases.
Okay.
But really they're just transformations of behaviors into noun form. So in my mind, a capability is really just another way of phrasing a stakeholder need or a use case, just represented as a noun. And again, nothing that I'm telling you guys is prescriptive. I'm not here to tell you that my thinking is the right way, but I'm sharing with you my thought process. I really don't see a lot of conceptual difference between use cases and capabilities other than how we phrase them.
How we phrase them, right.
Mm-hmm.
And the concept of a stakeholder, is that it's more fuzzy, I guess, from a capability standpoint?
I don't know that it's more fuzzy. It's probably equally fuzzy.
Okay.
Stakeholder is simply any entity that in some way shapes the design of your process or your system. That
Right.
stakeholder can be an actor who will use your system, or it could be a non-actor who imposes constraints on your system. Maybe a regulatory agency, for example. Or maybe it's a competitor or a hostile actor who wants to sabotage your system or steal data. So stakeholder really is any entity that informs and shapes the design of your process or your system of interest.
Okay.
So,
I have a question.
oh yeah, go ahead.
Sorry, the way you're kind of describing, writing use cases is that they're kind of adaptive and you're working with the stakeholder and like analyzing concerns and kind of getting feedback through that. Is there separately like a formal editing process for them to like ensure that they're very clear? Like, is there kind of like a secondary editing, or is it just kind of this like adaptive, or these like adaptive documents?
It's whatever process and policy your organization adopts.
Got it.
Now we're beyond the realm of language law or design methodology. Now we're really talking about process. What process does your organization have in place for editing model elements and for configuration managing them over time? Do you want every member of the team to be able to change the verb phrase for a use case? Or do you only authorize a certain subset of team members to make those kinds of changes? So there really is no answer that I can give you that's a one size fits all, right? Ultimately, it's really a question of human behavior and organizational policy. But I think what is unequivocally true is that you want to have some kind of change management system in place so that you don't have haphazard changes to your model that are not controlled by somebody in authority to do so.
Yeah. Thank you.
I have a
Good
question.
questions. Yeah.
So I've seen, you presented the use cases being refined from concerns. I've seen in literature and in practical projects, use cases coming from stakeholder level requirements, shell statement requirements. And then in SysML, there's actually a refined traceability from the use case to the requirement, right? Is that the same thing that we're talking about here, or would that be like a second step after what we're doing here?
It's an alternative to what I've been describing.
Okay.
So I'm going to go back and repeat what I said at the very beginning and what I said in response to Wes's question. I would like to reframe your thinking, and that's you plural, not you, Leandro. Right?
Yeah.
I want to reframe your thinking. I want to rewire your brains, because when you hear the word requirement, your Pavlovian response is to think shell statement.
Yeah.
But I want to try to break you out of that mode of thinking. And I'll say again what I said before. I want you to think of these use case elements as the stakeholder requirements, an alternative to writing a paragraph of text that begins with stakeholder needs. Now,
That makes sense.
in the next 14 minutes, I hope, I'm going to walk you through how to create a behavioral narrative that underlies each of these use case elements to tell a more detailed story. Because the verb phrase by itself is not a lot of detail, right? Stakeholders will naturally wonder, well, tell me what happens when a flight controller comes along and invokes execute home and transfer. That question is answered by the behavioral narrative that I'm about to show you next. But I want you to think of these use cases as the stakeholder level functional requirements. With that in mind, let's go forward.
All right. Thank you.
So now the time comes to do the hard work, and you apply the next heuristic. Heuristic number 5. I'll give you a moment to read that to yourselves. So now comes the hard part. For each use case that you brainstorm, for each use case that you derive from a stakeholder concern, you now have to write what we call the use case specification, the step-by-step narrative that describes how actors and your system work together to produce this emergent behavior that is the use case. And you can write that narrative in one of two ways. You can write it textually in English, or you can write that narrative graphically as a SysML behavior, either an activity or a state machine or an interaction. My advice is to do both, which may sound counterintuitive. After all, I am very much an advocate of model-based systems engineering. So why would I ever advocate for writing out a behavioral narrative in text instead of jumping right to an activity in a SysML model? Well, counterintuitively, when you get into a modeling tool like Magic or Rhapsody or Enterprise Architect or any of the tools out there, the mechanics of the tool can sometimes slow you down. If you were to open Magic Draw when you're sitting in the room with your stakeholders to brainstorm the first draft of that narrative, you're going to have a lot of people sitting in that room watching one person operate the tool, clicking on buttons and menus and windows, and spending time on making the diagram look pretty, right? Sizing things, spacing things, making sure lines don't cross. You will end up spending more time on the aesthetics of the diagram than you will on telling the right story. So my advice to teams, when you're sitting in the room with your stakeholders to draft that narrative, don't even open up that modeling tool. Just talk in English or whatever language you and your stakeholders speak. Sit around the table, get out a piece of paper or open up a Word document and just write out that narrative in English, step by step. Because in the beginning, changes happen very rapidly. The narrative is very volatile. You're adding new steps, you're deleting steps, you're changing the order of steps, all very rapidly. When you're in that stage of trying to draft the story, the tool gets in the way. So just spend time writing it out in English first. Spend a couple of hours in the room with those stakeholders, getting the story right. And once it's stable or stable enough, then you hand it off to one of the modelers on your team, and she takes it back to her desk and she turns it into a SysML behavior, activity, state machine, or interaction. That's my advice to you. Write out that use case specification, both textually and graphically. And I'd like to refer you to what I feel is a very good resource for this. A book called Writing Effective Use Cases by Alistair Coburn. And yes, he pronounces it Coburn, not Cockburn. He's Scottish and, dialect and all. But this is a really good book. It's not a modeling book. It's just a good book on how to write good use case narratives, how to brainstorm good use cases, and how to write good narratives. And he provides a template that I think will be very helpful to you. So if you get a chance, take a look at that book and take a look at this template. And when you're sitting around the table with your stakeholders, fill in this template to draft what becomes your textual narrative. And this one's only about 1.5 pages long, short and sweet. And once it's stable, you hand it off to one of your modelers, and she takes it back to her desk and she turns it into an activity diagram. And now you have it captured in the model itself, and you can create traceability to other elements. Sounds like somebody had a question.
Lenny, did you have preconditions and post-conditions in there in that template?
I did. Well, Coburn did, and I agree.
Yeah, okay. Yeah, that's a great place to start capturing that information too, to see what their expectations are, or what they assume that they may not have told you. Might have to be before this process starts,
Right.
like a
Exactly.
miracle or something.
Are you defining alternative scenarios at this stage, or just a happy scenario?
Yes.
Okay.
Is this how scopes are usually developed, or is, because what I found in the civil work that I've done is you given a scope, and that's what sets all of the requirements and all of the work that you end up doing. But this seems much more collaborative in terms of,
You said scope.
yeah, the scope of work that you actually end up getting paid for.
Boy, how do I answer that question? A scope of work is useful to only one group of people: lawyers and contract representatives. Rarely is a scope of work refined enough that it's actionable. When I deliver services to clients, I adopt an agile delivery framework where we build a project backlog, a set of concerns captured in the model itself. And that project backlog is in effect a dynamic SOW. At the end of every sprint, there's an opportunity for the client to add new concerns to the backlog or change the priority order of concerns already in the backlog. And often when we capture concerns in the model, we have a chance to talk directly to the end engineers that we're working with to elicit from them what their actual needs are. And we can often write these concerns in a much more actionable way than the contract representatives do when they write the SOW. The project backlog is in effect a better and dynamic SOW. So I'm kind of dodging your question because there is no good answer to it as phrased, but hopefully that was a good enough answer.
No, sure. Yeah, at least a goal at the very least.
All right, so I know we're coming up short on time. Let me leave you with the following and last heuristic. When the time comes to write this behavioral narrative, whether in textual form or in graphical form, how do you know that it's good? How do you know that you truly have a good use case, one that's at the right level of refinement? Here's what's going to happen to you in daily practice. You're going to come up with a use case that you think is good because it follows the other 4 heuristics that I taught you, right? It's a verb phrase, send command. It's unambiguous. There's no doubt what send means. It represents an actor's goal. It's written from the perspective of the actor, not the system. And it sounds like a behavior that an actor either invokes or participates in. So you've applied those other 4 heuristics and you've come up with what you feel is a good use case. And now you try to apply heuristic number 5. Now the time comes to write that use case specification, that step-by-step narrative. And here's what will sometimes happen to you when the time comes to write that narrative. You discover that really wasn't such a good use case after all. What is the red flag that indicates that it really wasn't a very good use case? And here it is. Heuristic number 6. Kind of read that to yourselves. So here's the red flag. When you begin writing out that narrative, if you discover that there's more than one main success scenario, more than one nominal path of execution running through that use case, that probably means you started at too high a level. Send command was too broad. And that tells you we should refine it. We should make it more specific so that it's more narrow in scope. To get it down to the level where it has exactly one main success scenario running through. And any other scenarios are simply alternative branches. Branches off of the main success scenario where things go wrong, errors and exception sequences. Your goal should be to hammer that use case down to a level of refinement where you end up with exactly one nominal path, one main success scenario. But how do you do that? How do you refine it to a greater level of specificity? Here's a couple of techniques. You can either use more precise verbs, or you can add qualifiers to the predicate. Instead of send command, how about send real-time command via uplink? Or send real-time command via forward? Or send stored command via uplink and send stored command via forward? Those would be 4 better use cases than the one you started with. They're more specific. And you may discover that when you write that narrative, there's now one main success scenario running through, and all the others are simply alternative branches. That should be your goal. You want to get it down to a level where that story is narrow enough in scope that it's clear to your reader. This story here, send command, will probably be too complex, too broad in scope, too hard to read and understand. So by getting it more narrow in scope, you make it an easier story to tell. And more importantly, you increase the probability that someone will actually read it. If you find yourself writing a 10-page use case specification, you have just greatly reduced the odds that anyone will even read it. It would be better to come up with 4 3-page narratives than 1 10-page narrative. It's really not very useful to come up with a good use case that is clear if no one reads it. Then it fails as a communication tool. So you want to hammer it down to a level where it's narrow enough in scope that it's clear and short enough that someone will actually take the time to read it. And that's why I recommend following heuristic number 6. But let me be forthright with you guys. I'm not here to be prescriptive and dogmatic. I'm not here to tell you that my way is the right way. I'm sharing with you some heuristics that I've developed based on training, experience, lessons learned that have been effective for me in my own practice. And if these heuristics resonate with you, then by all means, adopt them, go forth, apply them, and do good work. If not, that's fine. You can dismiss anything that I'm sharing with you in this presentation. These are heuristics. These are not standards. These are not language laws. These are simply rules for best practice based on lessons learned. And as with any heuristic, there are sometimes compelling reasons to violate them. But these should be your default mode of design. That would be my suggestion to you. And that's what I'd like to leave you with.
Very good. Thank you, Lenny. Follow-up questions for anyone?
Yeah, I have a quick question just on the order of the process. So you started with the concerns as the guide for the use cases, and then framing the use cases as like functional requirements or derived requirements. What about the iterative process? Do you then reevaluate the concerns and then reevaluate the use cases where does the feedback come in and how does that change, I guess, all of the follow through?
Well,
Or
I
what is
can't
the
answer that.
optimal? Yeah.
I'm sorry, what was there? I cut you off, I'm sorry.
I was just saying, like, what have you found to be like an optimal process for just making it as like evolutionary as possible?
The optimal process is one that is controlled and one that is easy for people to follow. And I know I'm being glib, but there's a reason. There is no silver bullet answer to that question, right? What is absolutely true is that iteration is an essential part of design. First draft is never the last draft. So yes, someone, system architect, chief systems engineer, project manager, someone should have the authority to approve changes to earlier work products. And that includes concerns and use cases. But the actual process for managing that change, there is no one answer to that question. And that's well beyond the scope of a 1-hour presentation. So all I can tell you in the abstract is that design has to be iterative. Waterfall as a process model fails. How you manage that change, that's a harder question to answer, and one that I think we don't have quite enough time for.
Sure. Thank you so much. Otherwise, fantastic presentation.
Thank you. I appreciate the feedback.
Those are all good questions. As I study SysML, and we keep it saying that SysML is a language, it's not a process. A process is a part of the 3 pillars of the system engineering, just like the tool is another pillar. And I liked how you talked about the tool versus the process versus the language. And this is something I think that is really important, Lenny. You work with the OMG to help define the language.
Yes.
But what you're talking now is about the writing. It's the literature. It's the style. You take that language now to create something, okay, that's useful in building an SOI, and I think that's wonderful, because what you're saying is we all, as system engineers, will develop a style, and as leaders, we need to set the standard for whatever project we're working on. So we understand who is doing this, who is collecting the data, and what's the iterative process to improve it. And I know you touched a little bit on agile, right? And you're kind of leaning toward that agile, which is less formal, more of the informal process, right?
Well, I guess it depends on how you implement it. I've seen some pretty rigid agile implementations. I've seen some pretty ad hoc implementations. It's really a matter of the discipline that the group applies to. Yeah, it's, the one thing that I've become painfully aware of in my career is that there is wide variance in how engineers do their work, right? Often we look for silver bullet solutions, right? Tell me the way, show me the path. And boy, there is no one path.
Right.
There is no one right way to design a system. There are many wrong ways, but no one right way, right?
Right.
So these kinds of questions, how, those are the hard questions to answer, right? There's a lot of ways to answer that question. Ultimately, what matters is not which path you take, but whether you're achieving your goal in the end.
Right.
It doesn't really matter which modeling language you choose, which modeling tool you choose, which modeling method you follow, how you manage change control. What matters is whether you're achieving your project goals. Are you producing a system that meets stakeholder needs on time and within budget? And if the answer is yes to those questions, you're doing a good job, no matter which language, method, or tool you picked.
Right. Yeah, there's this corporate culture we have to live in, and every, if anybody's been a contractor before, it changes every time you change a project, and system engineers, I mean, this is what we do. And I think in my mind, the sooner we get a better handle on the use cases of what's really the sooner and the better we understand and get feedback, hopefully from the customers. I always felt that that was going to be a higher success of at the end of the project, them being happy with what you deliver.
Yeah.
So, do you have anything else to say about SysML 2.0?
Oh,
Just
you were
just
picking
to
a
throw a
stab there.
little. Can you tell us anything about that? Where that is?
Be careful what you wish for.
Yeah.
Um,
Are you on that group with Sandy? Or?
I am. What can I say about SysML 2.0?
Oh, is it far away still?
Oh yeah. Formal release will be first quarter 2023. There'll be a beta release first quarter of 2022, but formal publication will be 2023. So it's still pretty far away.
Okay.
And we should not be so naive as to believe that SysML 2.0 is going to be a polished product. It's probably going to require 2.1, 2.2, 2.3 to turn it into a polished product.
Right.
But yeah, 2.0 is still about a year and a half away. It offers a lot to like. It also offers a lot to take exception with. It's hard to be specific without showing you the details, but it's a pretty radical departure from SysML 1.x.
Right.
In some ways, it simplifies things. It reduces the number of elements, which could be good and bad.
Right.
It flattens the learning curve, but it may reduce the ability to express nuance.
Right.
So that's one trade-off. In my mind, the biggest concern to me as a stakeholder is that SysML 2.0 will not be based on UML.
Right. They're supposed to separate that, right? It's becoming unlinked as a foundation.
It is. So I don't know how many of you guys are knowledgeable of the inner workings of the UML language. If you have studied UML, SysML, if you know what meta model means and meta class and stereotype. But if you've studied these languages and you know the bones of the language itself, then you know what I mean when I say the UML meta model. The UML meta model is a model of the UML language. It's a definition of the UML language expressed in UML form, which sounds like a kind of chicken or the egg kind of problem.
Yeah.
Right? How do you define a language using the language itself? But don't be too troubled by that, because that's exactly what we do with natural language. Think back to your elementary school years when you studied English language grammar. What language were those English grammar textbooks written in?
Yep. English, I think.
Yeah. So it's really not as ironic as it sounds that the UML language is defined in terms of UML itself. It's literally defined as a set of diagrams, a model of the language itself. So here's what concerns me, to answer Wes's question. There is a large ecosystem of modeling languages that exist right now that are based on UML, that are extensions of UML. SysML 1.0, UPDM for DODAV, BPMN for business process modeling, MARDI for embedded systems. And now SysML 2.0 comes along and it starts with a whole new meta model. It's in no way chained to UML, which in some ways is a good thing because UML has some bugs.
Right.
It has some defects that have been hindering the development of SysML.
Right.
And so the language authors intentionally started over from scratch with an entirely new meta model so that they weren't hindered by those congenital defects within UML. But there's a downside to that approach. SysML 2.0 is going to require completely new tooling because the existing tools that are based on UML and profiles of UML will no longer work.
Right.
So all the money that your organizations have spent on existing tools, well, I don't want to say it becomes a sunk cost, but you now have to buy new tools that will specifically support SysML 2.0. The current ones will not. And
Right.
that troubles me.
Yeah, so many organizations create their own stereotypes and shortcuts and definitions all based on the existing model. And I've always said writing scripts is great until they change, make one small change, the next version, then suddenly they all don't work anymore.
And that's a valid problem and a separate problem, right? This idea of ad hoc creation of stereotypes, creating this Tower of Babel phenomenon, right?
Yeah.
I could go on and on about the dangers of that. And
Yeah.
that's separate from this idea that SysML 2.0 is starting over from scratch. Again, my feelings are mixed, I'll be honest.
Yeah. Yeah. Well,
Question.
thank you. Go
One
ahead.
last question, Weston. For all the projects out there that are using SysML 1.0, when 2.0 comes out, is there a way to export from 1.0 that does the transformation, or do they have to start all over again?
A transformation model is being developed. That's part of the specification that the SysML 2.0 team is creating. They are creating a SysML 1 to SysML 2 transformation model, which is great, but it's a one-way transformation.
And that's just a specification. That's not actually a tool that does it.
Exactly.
Somebody has to go develop that transition tool like No Magic, so you can push that button and out comes 2.0.
Exactly right. So what the team is developing right now is nothing more than a standard. It's a set of rules that tool developers now have to go follow, right? So
that costs
they're going to
money.
spend the next year and a half just writing the language itself. And maybe sometime thereafter, tool vendors actually produce tools that are compliant with that new language. Now, if they're smart, they're probably doing it in parallel, right? They probably got a head start because they're members of the team also. No Magic, IBM, Spark Systems, they all have representatives on the SysML 2.0 team. So if they're smart, they're working in parallel so that tools are sold shortly after the language is formally published. But yeah, someone has to go create those tools.
Any more last questions? I think we gotta turn Lenny loose here pretty soon. I see his pop-ups coming up.
Just wanted to say what a great textbook. Really enjoy it.
Oh, thank you so much. I appreciate that.
I had one last question, if you don't mind.
Of course.
Go ahead, Ryan.
It's more pertaining to the courses that you offer. What, from your experience, I guess, what level of SysML knowledge do you think is needed to get the OMG SysML certification?
Well, I have to refine your question because there are many OMG certifications. There are 3 certifications for UML, 4 for SysML, and 3 more for BPMN, and I think 3 for Marty for embedded systems, right? So you probably mean the SysML certification, Jason?
Correct. Yeah, relating to your accelerator SysML training course.
So there are 4 levels of certification: model user, model builder fundamental, intermediate, and advanced, right? So what level of knowledge do you need to get those certifications? Depends which one you mean. Our training course, we offer a 35-hour course over a 5-day period that gets you ready for level 1 and level 2 certification. So it gets you halfway up the ladder to model builder fundamental. To get to level 3, intermediate, you then have to learn the other half of the language. It's a pretty big jump. And then for level 4, it's not even about SysML. Level 4, the advanced certification, is all about modeling methodology and language extension, meta modeling and profiles.
The
So
things that
that's
break.
a completely separate topic.
Okay.
I know that was a long answer, but hopefully a satisfactory one.
It's a good question, Ryan.
Yep. Thank you. I appreciate that.
Okay, well, yeah, my course is really just to get their feet wet and take them as far as I can. But I sure appreciate the work you do, Lenny, and we cheer you on. And I hope to see you in the future at the next NCOSI convention or working group. Is there a particular working group you want to recommend any of our students to join?
Well, if I did, I'd be a hypocrite because I'm not yet a member of a working group. I've been focusing with little discretionary time I have on the OMG. I'm a member of SysML 1.7 RTF and the 2.0 development team. So that pretty much consumes any free time that I have. I'd like to get involved with some NCOSI working groups. But I'm just not there yet. So I'm going to abstain from answering your question. Sorry.
Okay, thank you for your honesty.
Usually.
Okay, everyone. Thank you for joining our group here. Thank you, Lenny, very much for your intellect and your endeavors. Okay, so
Thank you. I appreciate it.
you'll be expecting something in the mail from me as a little a thing of gratitude. Okay.
That's really nice of you. I appreciate that.
My pleasure.
Thank you for
Lenny.
inviting me. It was really an honor.
No problem. Thank you very much. And thank you everybody for joining. And you'll see some of these questions in a future quiz. If I can read my notes.
All right, guys. Well, hope you all have a great night. It's been a pleasure talking.
Thanks so much.
Thank you.
Thank you.
Thanks, guys. Everybody.
Thank you.
Thanks, Yitzi.
Thank you. Appreciate it. It was awesome. Thanks.
That was fun.
Yeah, that was really cool.
Yeah.
Man, if this was in person, I would have got a signed copy of my computer PDF. You would have had to sign my computer.
I
screen.
always bring my textbooks with me when I go to an NCOSI meeting because I usually get Sandy to sign something or Lenny. I think Lenny did sign my book. I think I've got a Lenny. Oh, maybe he did. Maybe I had Sandy do mine last time. Nope. See, I got to take my book and get it signed.
See, the issue is I like probably somewhere illegally downloaded the PDF. So
Wait. Let me stop recording.
I mean legally.